Question 5, the question has asked us to choose any suitable complex function. So we have chosen f of x equals to x cubed minus x squared minus 17x minus 15. And the question also asked us to find x-intercept, y-intercept, open interval where the function is increasing or decreasing, the point of inflection, next the concavity, define the local minimum and maximum point, and lastly to sketch the graph. In order to find y-intercept, we have to substitute x equals to 0 into the function of x, and we will get negative 15. And then in order to get x-intercept, we have to equalize the function of x to 0. 0 equals to x cubed minus x squared minus 17x minus 15, and we'll get x equals to 5, x equals to negative 1, and x equals to negative 3. Next, to define whether the function is increasing or decreasing, we have to use the formula, the first derivative of x greater than 0 or f, the prime of x, less than 0. For the increasing one, we gotta use the greater, and we'll get x greater than 2.7370 and negative 2.0704. And for the decreasing one, we gotta use the less than 0 ones, where we'll get x less than 2.7370 and x less than 2.0704. Next, we gotta use d-test. And for the interval, we have gotten 2 points, 2 values of x. So we got the interval where the negative infinity to negative 2.0704, and the interval between negative 2.0704 until 2.7307 and 2.7307 until infinity. And for the test value for the first interval, we gotta take negative 3, for the second interval 1, and for the third interval 3. And the sign for the first interval is positive, where the conclusion of it is increasing. For the second interval, negative, it is decreasing. And lastly, for the third interval, positive, where the conclusion is increasing. Next, for the point inflection, we gotta use the second derivative equalized to 0. The first derivative was 3x squared minus 2x minus 17. Hence, the second derivative is 6x minus 2 equalized to 0, and we'll get x equals to 1 over 3. And later then, we have to substitute x equals to 1 over 3 into the function of x in order to get the value of y. So we substitute it, and we'll get y equals to negative 20.7407, and the point is 1 over 3 and negative 20.746. The value of x of the inflection point was 1 over 3, so we gotta put the interval from negative infinity to 1 over 3 and 1 over 3 to infinity in order to find the concavity. The test value for the first interval, we gotta take negative 1, and for the second interval, 1. It is advised to not take 0 as a test value because 0 is actually the natural value. So the sign of the second derivative of function x for the first interval is negative, where the concavity is downward. And for the second interval, positive, where the concavity is upward. Next, to find the local minimum and maximum point, we're going to use the formula x equals to negative b plus minus square root b squared minus 4ac over 2a. We gotta use the first derivative, where the a is 3, b is negative 2, and c is negative 17. Substitute a, b, and c into the formula. We're gonna get x equals to 2.7370 and x equals to negative 2.0704, since the formula has stated positive and negative. And to find y, we have to substitute x into the function of fx, where firstly, when x is equals to 2.7370, we'll substitute it and we'll get y equals to negative 48.5168. This is the point of it. And when x is equals to 2.0704, dy is 7.0354. This is the point of it. And to decide whether it is a minimum or a maximum point, we have substitute the value of x into the second derivative of function of x. When x was 2.7370, we will get the value, we'll get 14.422, where it is minimum point because it is positive. As everyone has known, the positive value will be drawn as smiley, and the point is at lower bottom, so it is minimum. And when x equals to negative 2.0704, we're gonna get negative 14.4224, where it is maximum. The point of it is at the bottom, so maximum point.
Okay, so as we have get the answer from 1 to 5, so we have to transfer to the graph, which is question number 6. Okay, so first of all, we have the x-intercept, which is negative 3, negative 1, and 5. So for the y-intercept is negative 15. Okay, so the interval where the function is increasing or decreasing is from negative infinity to negative 2.0704, and then from this point to 2.7370, the line is decreasing, and then from 2.7370 to infinity, the graph is increasing. Okay, next, the point of inflection is 1 over 3 negative 20.7407, and then the concavity from negative infinity to 1 over 3, the conclusion is concave downward, and then from 1 over 3 to infinity, the graph is concave upward. Okay, so then we get the minimum and maximum point, which is the minimum point is 2.7370 negative 48.5168, and then the maximum point is negative 2.0704 7.0354.